Hi guys. I don't think Chunmei will join us today. She's on vacation. I think
Yeah, she said that
we have the
last
full
week.
come here. Yeah. So I barely did anything last week. I just managed to the first thing I did is to add a flavor of a crimson to zip field. So it's a when we push to safe-ci repository, it in addition to existing two flavors like default and no TC-malloc, we will also have a crimson, which will produce
So
another package
you
named please, please go.
you said it also has. I didn't hear the last sentence.
Oh, the the net result is when you push to safe/safe-ci. Before this change, we only have two flavors like default and no TC-malloc. And after this change, we will have also a crimson flavor, in which it it will the package will build on Bionic with GCC9 and another package named Safe Dash Crimson OSD will be produced. The idea is it will be consumed by our technology installation task and will be integrated into our CBD test, which will serve as a baseline to be compared with our performance test integrating in our CI. Because Alfredo is still on PTO, so I will postpone it, defer discussion with him for later when he's back. So the next step,
Kifuro,
yes,
one question related to the tautology. I
yes,
thought before that the entity responsible for performance verification will be similar in concept to what we have with the make checkbot.
yes.
Do we have a plan? Do we have a change of plans?
No, I mean we want both, right?
We want both.
We need to be able to test it. It'll be a little bit before it's meaningful, but it's good to have packages. Anyway.
Okay, I see. We are having basically in two independent tasks. One related to tautology, one related to Jenkins, and like make checkbot verification.
Yeah, they could share the
Okay.
same task set performed by
Right.
CBT. We'll share the exact same set of parameters, so the net result could be comparable. That's the idea.
Well, also for correctness testing for tautology, we need to be able to actually start running the lower end thrashing tests. Whatever we can make work, as we make it work.
So could you repeat this?
Oh, I was just pointing out we want to be able to run the lower end thrashing tests as it becomes meaningful to do so. Oh, you may not be familiar with tautology. Tautology has a tremendous large number of failure injection tests whose job it is to run workloads against Cephbuster while killing OSDs, messing with the network, all that stuff. The stuff that tests.
Oh, okay.
There's effectively no other way to demonstrate that the OSD works.
But Sam, I don't really understand how it is related to the thrashing test.
Those are the thrashing tests. The thrash subsuite is the ones that do the failure injection.
Yes, but I don't understand how the performance test is related to the thrashing test.
They're not. They're totally separate things. I was saying that whether or not we were doing performance in tautology, we will eventually want the packages so that we can run other tests in tautology. Just normal bog standard.
Oh, yes.
Just so we can validate PRs and make sure we don't introduce regressions.
So in which case will tautology test to trigger for the Crimson OSD?
Right now, never, because it won't work.
In the future?
We would fail instantly. In the future, we'll have a Crimson suite, which we will trigger when we want it triggered, and then as it starts to make sense, we'll start making it more of a nightly thing.
Okay, you mean trigger manually?
Well, that's what we do now. The truth is the PR integration suites aren't triggered automatically. They're triggered by humans when, at least I'm assuming that's how Kifu and y'all still do it, but you sort of gather up several PRs, put them into a branch, and then kick off the test and then look at them the next day. It takes so long to run that doing them automatically isn't that good.
Once Crimson OSD is mature enough, we will schedule a periodically test to exercise the suite accessing Crimson OSD, which will also involve the selection test, as Sam mentioned. But it's a midterm plan. The short-term plan is to have a performance test using the Crimson package.
Oh, I see. So what's going to happen is when we want to validate a PR, it's going to push the branch to CI, wait for it to build, then pull the package back to the testing integration.
I think the plan to the CI will provide us with a baseline. What the master
I see. Okay.
performance looks like. Yes.
So in one case it would be built from source, in the other case it would be a package. I think it actually makes more sense to do the thing I just described. It should actually just push it. I mean, there's no reason why it couldn't work like that, right? Jenkins could push it to the CI and then simply pull until the package is built. That way it's the same system for both. That seems better.
Actually, that looks better, and I think Loic has implemented this quite long ago, but I never played around with it, never made it. But the idea is to offer the technology as and safe
No, I'm not talking about
CI
technology.
as a service. Is that what I mean?
No, that's not what I'm talking about. What I'm saying is, at some point, CI has to take the PR that's being tested and build it, right? So instead of doing that, it could push the branch to CI, wait for the branch to build, and then download the packages. That way it doesn't have to build the packages a different, separate way, which might not be the same. I thought that's
the same could be applied. The same could be applied to the already existing make a checkbox.
Yeah, that's true. We wouldn't need to do the build twice. That's totally fair. Yep.
Oh, actually that's a part of the plan to avoid building the package twice or building artifact twice, because
although come to think of it,
could be reused.
All the unit test binaries, I'm not sure they go into the package, so that may not work.
No.
No, in fact, I'm sure that they don't.
No, but we can use the pipeline of the Jenkins to package the artifact in the tarball, and
fair enough. Okay, that's probably fine then.
Yeah, that's a stretch goal of this CI integration.
Yeah, that's a good reason not to do the thing I said. That's better.
Yeah. So the next step is to check CBT and to make sure the task workload of a Rados bench won't involve some features we don't support yet.
Yeah.
That's the next step, and try to update the installation task to pull Crimson flavor for the Crimson flavored CBT test. That's the next step, and for sure I will review Sam's patch, look at it closer. That's me. And Radek.
I'm working on the input buffer concept. I pushed a couple of things. First of all is the PR for RFC, PR for Crimson, that makes use of the concept. I added support for basic alignment support. Another thing is extra patch is another concept introduced to the SeaStor part. There is a separate commit that allows to reuse the tile of the buffer. When reading with kernel interface, it's quite likely, well, it's absolutely sure for big chunks, that kernel will give you less than you requested. Currently, SeaStor ignores that memory, but for POSIX stack, the input buffer concept allows to reuse that. I also made performance testing. Let me provide you with some gist. The most actual performance testing is in the summary of the PR. Here is different one, earlier one.
This is the earlier one, and the result in
Yes,
the
the
PR is the latest.
Yes, exactly.
Okay.
Basically, the one in GIST is for a version that wasn't using scattergutter. Currently, everything in V2, everything important, use scattergutter. The read exactly is used only for short things. I believe that's the intention behind this method. Using it to get a big chunk, even while using POSIX stack, might be a misuse of the interface, I'm afraid. This is because the spirit of the interface is that SeaStor, that network stack, is responsible for giving you memory. And not only location, but even the chunk size. That's the reason why SeaStor has input stream consume, input stream read. All of them ignore the sizes. The network stack is responsible for determining them. By the way, Yingxin, I saw your comment in the PR,
Yes.
the last one about alignment for read exactly. What do you mean?
If you read exactly for a data chunk in POSIX stack, you may also need to confirm that the chunk of memory is aligned at 4K pages,
Okay.
right?
I see. That won't be the case really. The big chunks will be read as scattergutter. Always as scatter.
Sorry. Sorry.
Sorry, network glitch.
Okay.
The last thing I said was that read exactly, it won't be used anymore for reading big chunks. I believe it's mostly for dealing with headers that in situations where you would normally read, even if you would read with scattergutter, you would have made memcopy to have a contiguous space. That's the idea behind read exactly. Contiguous, one single contiguous chunk of memory that can be easily interpreted as a packet struct, for instance, as header. Just a reinterpret cast to a packet struct pointer. I believe that's the intention behind read exactly.
I mean, so if OSD is not backed by SBDK, by kernel interface, right? The data chunk still needs to be aligned to the 4K boundary, right?
Not entire data chunk. Segments need to be aligned, and well, it's much more complicated. Basically, the answer for the question is it depends. Just take a look for kernel device AIO.
What I mean is there's still a requirement that some chunk of data needs to be contiguous and aligned for 4K, right? For messenger.
Yes, and it will be.
And how to implement that?
Those chunks won't be read with the read exactly. Those chunks are big. Using read exactly would assume that that they must be in a form of one contiguous buffer, even if your network stack prefer to use scatter-gather. Read exactly is mostly for reading headers. It's for reading short things that must be contiguous because you want to reinterpret cast them to a pointer to a packed struct, like we have with CEF message header or something like that.
I understand, but what I mean is if it is a kernel device, the data chunk, the data segment, is data segment still need to be required to be 4K aligned or not?
It depends. If you are using direct I/O, yes.
So
take a look on the implementation of kernel device AIO sub. AIO write.
I mean, if we use that, if we must make sure that it is 4K aligned with data chunk, then we still need read exactly to read out the data, right?
No, definitely no. Really, just take a look on the implementation.
Okay, I think we can discuss later.
We are rebuilding the buffer. Okay, sorry for taking so much time. The problem I have at the moment, is using scatter alignment requirement for a very big chunks. Kernel gives me memory in chunks that are not aligned as well. It's fully expectable. The problem is that the temporary buffer of SeaStor doesn't provide a method for verifying whether two instances of the are connected, are spanning the same memory, the same single chunk acquired from malloc or not. That's very contrary to the buffer pointer, where we have access to the buffer row. Still, I have an idea. Idea is just to move the factory at the level of socket, and there we will have we'll be able to produce one big buffer, and any incoming buffer can be easily verified whether it's a big buff or not.
Okay,
I'm working on that right now.
Yes, I think we can continue to discuss the scatter gathering of segment alignment read buffer after the stand up. And Ronan,
sure.
How's it going?
Hi, I'm going over some PRs, and I have a few questions. If okay, I would like to ask them now.
Yeah.
One thing, I see you have added the blocking future. Yeah. The combination of a future and the reason. Am I right?
Yeah.
And and you started using the new futurized replacement to the store.
The what?
The future, the new SeaStor. The futurized.
Well, sorry, it's using futurized store because that happened under my patch. There was a change that just added an interface wrapper around SeaStor called futurized store. It doesn't change anything semantic; it's just a name.
And you're trying to create the error handling API to the store, isn't it?
No, this doesn't do the error handling thing at all.
No?
This doesn't do the error handling thing at all. This is a whole separate thing. The only purpose here is so that the logical threads represented by each in progress IO, we have a way of like listing them. It's not there yet, but we're going to add like an external. The classic OSD has this thing where it creates a Unix domain socket in a designated directory, and you can send it commands and get information back. And one of the commands, and you can send it commands that are like, give me the set of outstanding IOs, right? Because if something gets stuck, you want to go find out why. Basic debugging stuff. This will be vastly worse because if something becomes stuck, we won't even have a backtrace. So I'm trying to build that stuff in as a first-class thing, hence the blockers. The blocking future thing is simply because it made using it slightly less irritating. I'm not really tied to it. It still wound up being pretty annoying, so it's entirely possible there's a better way to do it.
Okay, I understand about the blocking. I was asking about, what I'm trying to say is that if you have already combined this extra functionality into the future blocking list, the blocking info, you might we want to add the.
We may well do that, but that particular feature doesn't really ever have errors, which is actually bad because there are a few cases where these things can short circuit that haven't been implemented yet. Specifically, if you're waiting on a PG to come into existence and a map shows up that says you're no longer mapped to this OSD at all anymore, there needs to be a path where you notice that and drop the IO, but we haven't done that yet. So I figure we'll do that with the next patch, or whoever implements that part will need a rational way to thread that through, and that'll be the right time to do the error handling.
Okay, I was thinking about instead of wrapping T, using in your blocking future, wrapping, including an element of future of optionality. Or
that's probably that may well be what we do, but actually for that one, it's probably going to be the case that the future that's in it will be the wrapper type itself, because the only purpose for that thing is so that when ops are doing are blocking on one of these things, they don't have a choice but to do the correct order of registering the blocker and unregistering it. Otherwise, someone might forget. It may turn out to be non-performant, in which case we'll have to figure something else out. I'm kind of guessing the compiler's going to do it for us, though.
Okay. And two more questions. One is, what is the priv in OSD connection priv?
Oh, private. I'm sorry. Yeah, I probably should have just called it private. Oh, I can't because it's a reserved word. That's why I didn't call it private.
Okay.
It's an arbitrary pointer that the user of the connection can use to associate state with it. In this case, what the OSD is doing is it's for every connection that comes in, it's associating two blocking lists, one for peering IO and the other for client IO. Otherwise, we'd have to maintain a mapping from connection pointers to these things, which is just another lookup. Classic OSD does the same thing. It's not super unusual.
Okay, I was trying to understand what it's there for.
Yeah, sorry about that. I could add like more verbiage around it, but I think usage is probably, like if you notice inside of OSD/, there's a little helper that just always pulls out an OSD connection priv with those two types on it.
I remember the code. I didn't remember it was okay.
Yeah, it's clear that part isn't clear though, so I'll add a little bit of text.
Okay, and another general question is regarding no except. In some instances, functions that we are writing.
I didn't add that anywhere. I probably should have.
I think we better do it whenever if there are no failure mode apart from memory allocation, which I don't think we should handle with exception.
Actually, well, yeah, but I think if it's no except and it really does throw, I think you break C++.
No, it's terminated. It's defined. It's not undefined behavior. It's very defined.
Yeah, so if you do no except, but you do throw an exception, it terminates at that point.
Yeah, it's called std terminate.
Okay, that's not so bad. Yeah, we haven't done that anywhere else, but that's a good point. We could go through and annotate.
Because I noticed some of the code I tried on the side produced better results.
I mean, we could actually just disable exceptions completely.
Well, that probably would ruin using it, because if you
No, I mean you can do it as a compiler option. That it just never generates the.
But then you have problems with some include files with have try-catch blocks. They will be flagged as
actually, yeah. Now that I think about it, buffer list does that. Encode decode. Okay. That's a fair point. That might or might not be worth addressing on this PR, because it's actually true for almost every piece of code in Crimson. Actually, I didn't see no except anywhere. Let me go check. Maybe I'm wrong.
I don't think so. I think one or two instances.
It's just neterrors.cc and one place in config proxy. So that wouldn't be, you may want to add as a task and do it separately. It would be a good patch for many respects, actually.
Okay, I might try that and comment a few other things that I wanted to fix.
Did you have other questions?
Not that I remember now. Probably I have. I'll send it.
Yeah, I'm particularly unsure that the way I did the peering messages is readable. I think Kifu maybe alluded to that this morning.
I actually liked it.
Since we're on the topic, Kifu, was that what you felt didn't go well?
Yes, the combo message. I just don't really like how we extract part of a logic in PG and OSD into that part. That's
oh, actually, that part I did on purpose.
Little distracting from the regular point of view.
Yeah, so so there are two basic ways of doing this. You can either embed the handling for each step into the relevant piece of PG or OSD code, depending, or you can yank it out and force there to be interfaces from OSD and PG into this extra class that now everyone has to read, right? So
yes.
I actually claim that this is less bad. The reason is because we always spent a lot of time explaining to people the code flow as you go through OSD, because you have to hop, it's like MS dispatch, then it goes into the thing where it finds the PG, and that pathway is actually quite complicated. Then it needs to go through two different queues to get to the PG, at which point there's a whole sequence of blocking queues it needs to go through that are in different places, like physically in pg.h. Then it goes into replicated PG, and there are different locks it needs to take there on the object context, and also the pathway through cache tiering is really very hard to read. So my claim is that doing it this way is better because it forces PG be, in a sense, ambivalent about how the interfaces are being used. It provides ways for the IOs to agree on ordering, but it's this file that determines how an IO actually goes through. Most of the code will still be in PG, of course, but because the code that actually matters really is there. But you'll be able to look at this file and say, okay, these are the 10 steps it needs to go through.
I like it too.
It's a different approach. I agree. It does require you to look at a new file. For instance, I just declared it to be a friend of PG because there's no meaningful interface boundary there, right? That's not a win here at all. It's just that we get to define the state for an IO in one place, and that is the state that it carries through all of its steps, and we get to define the order in which it moves between pipeline stages. It's less clear for peering because the pipeline is pretty short, but I feel that it is more clear for the way I did client IO, if you want to look at that file. And in the future, I would expect to pull out even the part where it grabs the object context locks and any future blocking it needs to do below that, if we ever do cache sharing. Things of that nature would also get surfaced up into this file.
You're taking a pg.h or pg.cc as a service provider and put the policies and the consumer of it into a different.
In a sense, it's or to put it another way, everywhere where you block on a future should be in this file. That way you can see all of them. Everything that's just straight line code that just like does stuff is over in PG. So PG does stuff.
Even if it's only a really sequence of blocking, but a sequence of one operation, not
and that's
one calling the other.
That's where it gets fuzzy. Like this, I'm not saying it should happen this way. I'm saying that all the big important blocking states should be surfaced up where they're easy to find. That's all. But there will probably be internal blocking states inside of PG backend, and I am uncertain about that. It may make more sense to wrap that up as I'm just blocking on this thing PG backend is doing, or it might make sense. I'm open to suggestions. I think it'll become more clear as we do that part. But I did want to at least surface the part where you have the crossbar from I'm a thing that came in on a connection to I'm a thing that's ordered in the PG. That part is now sort of surfaced explicitly, and I like that part.
And it's helping me understand what's going on.
Yeah. Classic OSD is really, really hard to read, and it's like 50% because the number of different like hopping through all of the lines of code that touch an op in order is very hard. It takes a long time. I'm not saying we have to do it this way. I think that's my argument, though.
Yeah, I just want to understand the philosophy underneath this decision. So
yeah,
it's kind of clear.
I make no claim that this is the best way of doing it. I tried to make it. I introduced this pipeline concept, where you have a handle that is attached to a pipeline stage, and you enter the next pipeline stage to allow a new op to come into the previous one. So you get sort of a logical progression of blocks, if you will, but with the benefit of concurrency. Essentially, it's Crimson's version of a sequence of work queues, except with no work queues threads or blocking of any kind. It won't actually do any blocking if there isn't another op there, but it means, for instance, that if we have an op waiting on an OSD map, everything behind it will wait too. They won't skip the line. So that kind of surfaces as a new feature that gets inserted between some of the steps, which I think makes it easy to read, relatively speaking, for now.
I do have another question, but I will leave it for after Yinxin's summary. And Yinxin?
Okay, so the first part is I'm still working on the alignment issue, and I pushed up the SeaStor part of the PR, and I will use it as a baseline to compare Redux implementation, and I still need to be aligned with him about the alignment requirement, specific alignment requirement in the messenger. And what I want to know is that if we really need to do such intrusive modification to SeaStor to just for the specific case to reduce for the specific case of the POSIX socket case, I think it is very specific case now, because I also saw about IOUing that there's a mood for IOUing that there will be no system calls. It's called SQ poll. There will be no sys calls during IO with kernel side polling. So I think that the POSIX socket is a very specific case. So if we can do it cleaner and non-intrusive, maybe I will make sure if it benefits. So that's why I'm also working on the perf Crimson messenger to get better understanding of the performance, because I need to add the latency sampling, because I need to know each message latency. Before that, I need to send each message one by one on depth equals 1 to know the latency of the to send the message. But with sampling messenger, I don't need to do that anymore. And I also need to add timer to limit the running time of the perf and add per second report, because for the aligned memory allocation, it seems that the performance is very unstable even across different tests. So I think per second the report is better for that. And I also reviewed Sam's patch, and I currently my understanding that you are building up M to N mapping with operations and blockers in the previous version of your PR, right?
Yeah, and it went a little bit further in that direction.
Yeah.
That's part of it. The other part, well, if you look at the client request one and the new one, I think you'll see the end goal.
Which one?
Client request.h and cc.
Client request. Okay.
Or client something. Probably client request.
Okay, thank you.
So I'm trying to understand. Are we saying that because we see what the future is going to be, that we can keep the final parts of optimization for socket-based readings? We can just keep this part clean and keep this part clean and leave the rest, optimize all the rest. That's what you're saying?
I asked me, also, can you repeat?
I was saying that we should just not bother with optimization, final steps of optimization for socket-based reading, and keep it clean and perform all optimizations for other methods.
What I mean is that if we have a less modification to SeaStor and get a similar performance, maybe we don't need to modify a lot.
Well, currently the patch for SeaStor is much smaller. The input buffer factor is much smaller when it comes to size.
Yeah, but also, I still want to know the performance.
Sure.
As a baseline performance, if it really improves a lot. Yeah. That's two goals.
Well, I don't expect it will be there will be huge difference between those for the POSIX stack. The main idea is to keep the interfaces of input stream clean, to preserve the abstraction SeaStor folks already made. I mean, to have the same, to not enforce users to read at the level of the interface, to read differently for DPDK than they are reading for POSIX stack. That's the main goal of the input buffer factory. Keep the abstraction the current interfaces provide.
I still don't understand why we need to differentiate the DPDK stack and the POSIX stack when we read from.
Just take a look. You introduce the alignment to the read exactly. It's a killer for DPDK. If you want people to use read exactly with dealing for reading the content from the payload from SeaStor, likely they will need some kind of if DPDK, then not. If SeaStor, then that.
Yes, but the different logic should already be encapsulated in different data source in IMPL, right? So from user side, there's no difference for the input stream. The difference should be encapsulated all within the data source.
I disagree.
No,
we
cannot.
Okay, let's finish the discussion after the main part. the main meeting.
Okay. So that's all from me. Tofu?
Okay, Sam, I just have a very quick question regarding to the private thing. Actually, Yingxin had tried to replicate the interface from classic messenger to add the get setter of a private thing, but I stopped him because I was concerned that we will open the door for the circular dependency, but I found that the private is the unique pointer. So I just wanted to check with you. Will we to make sure we won't abuse this interface for add a pointer to the
OSD.
Yes.
I mean, that's in a sense exactly what we're doing, except that we're definitely not. What we're doing is we're attaching some state to the connection that will be useful for us to have when a message comes in. In this case, it's just these two. Wait, what are they? They're really just they're just SeaStor mutexes actually. They're just two of them.
Okay.
One for that's all that's not struct. I mean, we could abuse it to do something silly, but the other option here is to like track connections and like add a map or something, but then we got to clean them when the connections go away. You have to look them. I mean,
yeah.
Just sticking a pointer on the connection seems like.
I just want to make sure we are on the same page. We won't abuse it for point.
Yeah, well, the purpose of this thing is if there's state that is associated with a connection that you want to get to quickly, and it makes sense to put it on the connection, I guess. But in a sense, this really isn't a pointer from the connection to the OSD in the sense that there's no way for the messenger to actually access this stuff, right? If you look at it, it's a unique pointer to a totally empty interface.
Yes,
whose only purpose is to have a virtual destructor. In fact, that's the only
currently it does not violate the idea.
Oh, okay. So to be clear,
but
I don't expect that interface to ever have anything else in it. That interface and OSD connection should always be totally empty. In fact, if I actually looked, I assumed there was a deletable interface already somewhere in the standard library, but sadly there is not. So this was the only way I was able to come up with to have a void pointer that I could actually delete. If there's a better way to do that, definitely tell me.
I'm the word that we won't use for other things and keep the private thing as simple as possible. Which we want to have a strong reference to its upper level. That's If we have it, we're on the same page. That's good. That's fine. That's good.
To be clear, though, if there's a better way to do a deletable, I'd rather do it that way. I don't like the empty interface. It's clumsy. I just wasn't able to find a better way. So if anyone's got a better idea.
Otherwise, we will have a map in PG or OSD.
Well, I definitely don't. I claim that this is such an obvious win that we definitely want to do that part. The interface will always remain empty because the only reason why it's there is so that we can delete it. But the implementing thing will just have whatever stuff the OSD wants to associate with a connection, whatever that happens to be. Classic OSD used to associate some or does associate some. Sorry.
Sessions, OSD sessions.
Yeah, exactly. Session-like information. So that's kind of like what we're doing, but we don't have stateful sessions here, so not really necessary.
I was thinking if S to any might be you don't have. It's very similar to this virtual nothing that virtual destructor that you have created.
But that's literally all it is. Like if there's a more correct way to do that, I'd rather do it that way. I just don't know of one. Like there isn't an obvious. Nothing stood out and announced itself when I Googled around. Kind of an oversight in the standard library. It would be nice if you didn't just have to invent one of these interfaces to do that.
What I was hinting is, I want to check if std might be used in this.
Oh, sorry, what's that?
Std, std ... any.
Any.
column any. It's not what its main use is, but
Oh, this uses RTTI. I don't actually want to do that.
you're right. You're right. Don't.
Gets close though.
Okay.
Anyhow.
Any questions, guys?
Yes, Sam, I just pasted a PR here to make I implemented it to make the message blockable.
Yes, I was actually sort of assuming that something like this would exist.
Yeah, so.
I'm not sure that it's strictly necessary, as it turns out, but I do think it's better to do it this way. And the reason for that is, actually, this is a good question. What happens if we block for a long time on a single connection? Does it block all dispatching in the messenger or just on that socket? So I'm basically asking this: Can we block further messages coming in on a socket by blocking in that MS dispatch thing, or would that mess up the whole messenger?
No, if we don't, currently there's no way to block message
Oh no, I mean with your patch. Well,
yeah, with my patch, if you block MS dispatch, you will block the messenger read.
Okay.
To block the further read from the messenger. But before this one, there's no way to do that. Messenger will try to read and the commit dispatch message.
I'm thinking ahead a little bit to throttling.
Yeah, we will have throttling, but it's messenger throttling. If the OSD is very, very slow, the messenger will not understand that case.
Right, and more to the point, it won't. If we try to implement QoS, you can't selectively slow down one connection.
Yeah, that's true.
We'll just have to do that later. Okay, that's totally fine. Just us.
Yeah.
In that case, actually, I think we shouldn't do this your patch, and we should leave it on. We should leave it for now. I don't think it's strictly necessary for my patch to work.
Okay, so yeah, we can leave it.
Yeah, I think we're gonna need something like this eventually, but it's gonna need to be the case that that blocking dispatch on one connection doesn't block dispatch on other connections.
Okay.
I think probably, assuming that seems like the rational way to implement throttling, but we'll have to think about it. Anyway, That's not a problem for today.
I do think we do support throttling at this moment in Crimson Messenger.
And
we already have it.
Well, QoS is different, right? Throttling is throttling everything. We're just throttling the total number of messages on a connection. But the OSD might want to be like, actually, I kind of just don't want this client. I just don't want to see any messages from this client for a while. I need to do other work, so just like stop. So if we can do that at the MS dispatch interface, that would be cool. But if we can't, then we'll do it a different way. Whatever makes sense. And that's some ways in the future anyway.
Yes, for example, if we want to use a DM clock interface,
exactly.
we should be able to hold down. Yeah.
I'm only asking insofar as it sort of informs my understanding of how SeaStor works. We don't actually have to worry about QoS now. I was just curious.
Yeah. So, any questions, guys? Anything else? Okay, have a good day. And
have a good day. And congratulations again.
Okay, thank you.
Oh yeah.
Oh, by the way.
Congrats.
By the way, we will have Evie was asking if we can attend the SeaStor Meet in November. So I think I, Sam, and Riddick will attend the meeting.
I
By
talked to
then we
Sam,
will.
he's fine with it. So.
Okay.
Okay. I'm not sure I will be able to, but
Okay. So good. I later. And
Bye.
see you.
See you.
Bye.
Yingxin, are you there?
Yeah, is it still recording?
Uh, I think so, but
Okay.
not entirely sure.
So I want to understand. So just for data segment,
Yep.
what's the correct behavior to read? So which
Unknown at
case?
the unknown speaking technically, not entirely defined the level of messenger. That's the problem. The requirements, whether about alignment, about number of chunks, using single chunk, using few chunks, using huge number of chunks, can be known only at the layer of storage, of the driver that will be underneath the SeaStor.
Yeah. So
Currently,
what I mean is that the messenger should expect a configuration of the behavior, how to read out data, right?
I disagree. That way you would need a very, very complex, frequently changing interface that would interconnect messenger with not even with futurized object store, with a particular with some registry of drivers inside futurized object store. It's cumbersome.
Okay, then how to decide?
Don't try to decide at the level of messenger. My attitude is just to handle network payload in the form recommended / enforced by a particular network stack.
Okay,
Surely,
so it is decided by network stack, not by anyone else.
Yep. In general, at the level of interface, yes. However, some network stacks, like the POSIX one, are more flexible in terms of available of memory management than others, like the PDK. However, it's not visible at the layer of input stream interface. That's the reason why input factory is fully optional, both for client and moreover for network stacks. TPDK won't use it.
Okay, so to read data segment, we just need to we don't use read exactly anymore. We will use read fragmented interface.
Exactly. That's the way. That's the idea. Currently, it was changed from the patches for CEF for Crimson already changed. Already have changed the way how we read data segment. Read exactly is used at the moment only in 3 places for reading epilogue, for reading preamble, CEF banner, and epilogue. Nothing more. All of those guys are around are smaller than 32 bytes. They are very small, and I believe that's the reason. That's the idea behind read exactly. It's mostly for handling headers, at least in my impression.
Okay, so what do you mean by the data allocator. What's the name? It is intention of the SeaStor. What do you mean that?
Don't get you.
The
data allocator. What do you mean?
Let me find the code.
Input buffer factory?
Yeah. Input buffer factory is intention of the completion of the SeaStor input interface. What do you mean by that?
What is the intention behind input buffer factory?
You have said that the input buffer factory meets the intention of completes the intention of the SeaStor input stream.
Okay, I think that the IFB just stays consistent with the current interface of input stream. It doesn't affect it at all, to be honest.
Okay. You mean that the SeaStor modification don't have much impact, right?
Right.
Okay. So
it's well, for SeaStor it will be small.
okay.
Basically, all it does is delegates for some network stacks. It delegates the responsibility for acquiring memory to application, but only for those network stacks that are flexible enough, like POSIX stacks. If a network stack in a particular network stack is less flexible, just won't use the IFB. IFB is optional. It's voluntary.
Well, IOP, which is optional, optimal.
Input buffer.
IOP.
Sorry, buffer factory.
Okay, so only POSIX socket will use input buffer factory,
Maybe
right?
the TLS as well, something like that, but
because
definitely not DPDK.
Yeah, the PTK will ignore that, and the IO urine will also ignore that because IO urine, there's some mode in IO urine that will not have system call on during its IO. It said that the IO urine's SQ pore model will not incur syscall during IO, will not incur any syscall during IO. I just saw some article.
I saw.
That.
Yeah, that's currently the polling. Even now, the polling for completion of your events doesn't require any syscall. That's even this is true. This stays even with the AIO, with the current AIO interface. This uses that hack. Basically, the inspection of the completion queue that is exposed to user space, it's performed by SeaStor without any interaction with kernel at the level of syscall. Kernel exposes some memory to user space, and SeaStor makes use of it by just going through the queue on its own.
Do you think it is related to the input buffer factory?
No, it isn't, but not directly. The indirect bound could be because IO urine could neglect the need for prefetching.
Yes.
That's the only junction point I see. Currently, the network for POSIX stack, we will want to do polling for the sake of very small things like read requests, which are around I bet around a few hundreds of bytes.
Okay.
But prefetching, well, it's just basically doing more work just because the SeaStor interface is so weak, is so poor. Because because it's so outdated. When it was designed, the cost of SeaStor was difference between speed of CPU and speed of storage was so huge that nobody was taking care about such details like mode switch.
And it complicates your code.
To be honest, I would love to kill the prefetching at all and entirely. And IO Uring makes some promises in that matter. If it's performant enough, if it lowers the cost of exchanging some data with kernel, communicating with kernel enough, then we won't need to do the mem copy imposed by prefetching. We won't need to do prefetching at all.
Yeah, but we still need to implement that because it should be compatible, right?
That's actually a very good question about this is about, well, if we want to go, if we would need to release Crimson OSD right now, yes, we would need that. Definitely, we don't need that at the level of SeaStor. If it will be at the level of client, at the level of Crimson OSD. So the part of IBF for SeaStor is free of that, and I believe that Crimson OSD will be released in maybe 2 years from now, and I'm just speculating. Maybe we will have IO Uring widely available at the time.
Yes.
Roland has posted. Roland posted some time ago a link to tweet from Yaniv Kal. This guy is one of the storage bosses at Red Hat, and in the tweet he said that IO Uring will be backported even to very old HLs.
Okay, that's a good news.
Yep. Also, in the Barcelona, I had also a talk with Ilya Droimov, the guy behind KRBD, our kernel developer. I asked about portability of IO Uring, and he responded, it's quite good. The subsystem basically is nicely isolated from the other kernel, so it's more like just adding, it's just like a transplantation. You don't need to mess with other kernel subsystems to get backported.
Okay, so for our currently, we still need to consider the kernel POSIX because we don't know what will change in the future, right?
Well, we definitely need to be ready to implement prefetching. I'm absolutely agree on that. We need the interface must be powerful enough to allow also prefetching.
Yes, I agree.
I'm not sure we need to implement prefetching right now. However, for reads, it might, well, if we don't do, there will be maybe 15 to 20% of penalty for reads.
Yeah, I'm evaluating. I'm trying to evaluating that, but I'm still working on perf Crimson Messenger.
I see.
I will do that to see for at least for 4K, how much benefit can we get from prefetch?
For 4K, well, I was taking a look on that for 4K writes. I mean, do you mean 4K writes, right?
4K read, prefetch read.
Okay. For 4K reads at the level of radios or at the level of
at the level of the at the level of the messenger.
At the level of messenger, okay.
And
So
at the
read
level
at the
of
level of
read.
messenger will be right 4K right at the level of Rados.
Yeah, and read 4K from, and I will see because your PR currently doesn't prefetch across 4K, right? And
Exactly.
I will compare that with the implementation with prefetch across messages.
Yep. In my testing, I'm seeing slightly, maybe 5%, below 5% impact for 4K. For 8K, well, it depends on testing. It's basically around the measurement error. In one test, it's version without perfection is more performant. In another one, opposite happens. Basically, it's very close. Both of them are very close to each other.
Consider the data trunk smaller than 4K, like 100 bytes.
Yes.
100. And do we still need?
We will need really because of handling handling Rados reads.
Okay, so yeah, so for RGW it is not 4K, right? You mean?
For instance, yep, for RGW it can be smaller.
Okay. Yeah, so I should still evaluate the smaller block sizes, right? Okay.
Yep. Read your comments about the idea to use different methods for SPDK, different for non-SPDK.
Mm-hmm.
And well, my point is that we can do that. However, it has some issues. The main one is that basically at the level of messenger, you don't know the exact requirements related to the output of your network payload.
Yeah, so to read the payload, we just read it as quick as possible and don't need to bother the alignment, right?
Yes, exactly. Just take a look on the kernel device AIO read. Let me paste a few lines. There is an if. And here it is. That's the if responsible for rectifying buffer list. As you can see, the buffer list doesn't really need to be contiguous. It's perfectly fine.
Yeah.
If it's fragmented, but depending on couple of a few factors, like whether you are doing direct I/O or not, how big your kernel vectored I/O can be. It does the rebuild of buffer list or not.
Yeah, but I'm still a little confused that because the V2 protocol is enforcing that the data.
Yeah, it's nasty to be honest.
We need to remove that, right, for the async messenger. Remove that requirement.
That's basically an optimization that leaked not only across the API, it leaked even to the protocol. I'm not really happy with that, but it happened, fortunately.
Yeah, I think it's easy because the protocol, it is not fixed that the segment alignment is not hard coded, because if you can in the newer implementation, if you set the data segment alignment to the not aligned to no aligned, and that will solve all the problems, so that async messenger knows that the data can be fragmented. So the only change is to change the data segment alignment to not aligned.
Well, to be honest, I treat this flag just as a hint.
Oh, it's okay. Not, that's a hint. It's not a requirement.
Exactly. We are marking a segment that we know that that OSD implementations usually will put to storage device, and for storage device, as a rule of thumb, it's usually good to have it aligned to 4K. But well, it's just a hint. It's very, very far away from the real complexity of memory requirements imposed by particular device.
Yes.
Well, SeaStor is very good example of that.
Yes.
It offers many drivers for block. There is implementation, of course, at the top of AIO, the most dominant Linux AIO, the most dominant one. The fragment came from it. However, there is also implementation based on SPDK. There is also an implementation on top of PMEM.
Yes.
And well, even if we
apart from that, what I really mean is that in the Crimson Messenger is not very different from the async messenger. So if Crimson Messenger totally ignores the hint of the alignment of data segment, it just read as quickly as possible and ignore the alignment requirement, right? For the data segment. So why not async messenger ignore that? Because they basically same, I think.
Well, because async messenger deals only with POSIX. It's very easy for POSIX. POSIX stack is flexible. It must do the mem copy between kernel and user space for the sake of isolation. Mem copy / mutrix to remap pages. Anyway, it offers you very flexible interface. In case of POSIX stack, user is responsible for providing memory. So changing malloc with POSIX mem _mem aligned is not a big deal. Okay. But the situation changed entirely in case of not even but even at higher level in the case of SeaStor networking. And SeaStor networking is actually driven by DPDK. All those methods doesn't offer you any pointer taking variant. Memory is allocated by stack, and most of them even lacks a possibility, even ignores don't offer you possibility for you to specify how many bytes of the socket you want to read. It's still determined at the level by network stack. It's very, very different than POSIX stack.
So async also has DPDK stack, so it will be a different implementation for asynchronous messenger with DPDK, right? Because currently they are the same.
I think so. It will be just different messenger.
The async messenger also has DPDK backend. So currently, if async messenger is backed by DPDK, it also do the same thing to make it aligned first and.
Okay, so you are suggesting that its performance can be also bad, like
yes.
so.
Yes,
like
I
so.
think so. I think so. So that's one problem of the async, right?
Yeah, to be honest, we haven't tested with DPDK while doing the V2 stuff.
Okay, I just need to understand this very clearly to implement Crimson method.
I see. Still, if there is a possibility for some stacks to make better decisions, maybe even optimal decisions, it still might be worth exploring.
Mm-hmm. Yeah,
That's
sure.
That's the idea behind the input buffer factory. It's not obligatory for any stack to be used. If an implementation of the SeaStor interfaces know that its memory management is flexible, it can make use of the provided factory instance. So for instance, to make alignment, to specify chunks, the size of chunks for interaction with network device, things like that.
Mm-hmm.
But definitely, it's not narrowed down only to the alignment. That I believe could be nice. That I hope it will. It could help convince SeaStor folks. It might be harder to justify bearing alignment as an extra part to some methods than just some more abstract concept that allows application for more. In short, what I'm trying to say is that the input buffer factor is more generic. Okay. It can provide applications with more more features.
Yeah, and it only is a hint, right?
Yes, it's not obligatory. Exactly. It's not obligatory for both application and network stack. If application lacks input buffer factory, that's fine. If a particular network stack implementation lacks stuff for input buffer factory, that's also fine.
Yeah, I know, I understand.
That basically, well, to be honest, that's a good point. I should rename the parameters in SeaStor functions from IBF to just hint IBF or something like that.
Yeah. Add hint is more
yes,
clear.
The same. I believe the same is with the alignment in V2. It's
true.
A hint.
True. Yes.
It's just a hint.
Yes,
it's a requirement. Basically, it would mean that DPDK will be never performant.
Mm-hmm. It will be very confusing if someone misunderstand it is a requirement.
I agree. Yep. It can. Well, it might be that if somebody understands this as a requirement, he would do a lot of extra work just to satisfy the requirement, but this extra work this extra work will be even prohibiting for efficient consumption by some storage devices like SPK.
Yes.
Some storage devices. Actually, well, we should rename both. in SeaStor and also in Messenger, I think.
Yes.
It's a hint. It's just a hint. Previously, it was, well, there is no difference if you are not trying to support more, if you are not trying to support the DPDK efficiently. Then it's no difference between hint and requirement that matter. But adding the efficient DPDK consumption, well, changes a lot.
Yes.
Okay, I will try to resolve one big problem I've got. I faced when implementing the alignment support. As you saw in the gist, with dump of a buffer list produced when reading formex, it's fragmented. It's very fragmented, and moreover, it's not fragmented at the page boundary.
Not fragment at page boundary.
Yep, just take a look on the here's address of one of the buffers. As you can see, it's not aligned to page size. But what is funny is that all those fragments are contiguous at the level of the memory buffer. But logically, at the level of the buffer list, they are fragmented.
They are fragmented.
There is a method in buffer list targeting exactly cases like this one. There is a special variant of append. It's posting. It has a special optimization for cases like that. Or the easiest thing is just to grab for a comment. Yeah, it contiguous with tail. This append to buffer list tries to
make them continuous on the memory,
yes,
right?
If the underlying memory is contiguous, then it tries to restore the order at the logical level. But actually there is a problem with the buffer row, depth buffer row implemented on top of SeaStor's temporary buffer. Actually, each temporary buffer instance, when turning to buffer pointer, gets its own independent buffer row, which means that the optimization here won't take place. And actually, there is a very good reason for our implementation of the adapter between buffer row and temporary buffer of SeaStor to behave that way. It's because the temporary buffer of SeaStor doesn't offer you any interface to check whether two instances are basically clones, are spanning on the same physical memory.
Okay.
That's unhandy. Well, I would prefer to not introduce, don't touch the temporary buffer. Unfortunately, there is a way to avoid doing that. A comment in the PR that I want to move the factory at the level of socket.
Yes, I saw the comment.
Yep, this means that that both reading and creating a memory for those reads would be performed on the same level by the same entity. It allows to restore the order of the incoming it allows to not fragment the buffer list at all.
Not fragment buffer list. Okay.
Yep, to make something like the optimized version of the buffer list append does.
Will it be in your future implementation?
I'm working on that right now. I
Okay,
hope I will have a patch today.
I will review that to understand what you are saying.
I see. It's always easier to take a look on code. I have the same. It's better to take a look on the code than try to understand from voice.
Yeah, I think so.
Okay, I will add first of all, I will focus on the implementation and add some comments add some responses to the comments in PRs later.
Okay, I will continue working on perf first.
Okay, cool.
Okay, thank you. Vedok.
Thank you. See you next Wednesday. Bye.
See you next meeting.
Next meeting.